Hello guys, welcome back. Okay, yesterday we have discussed about fin. Now let us discuss about fin equation. Yeah, these are mind scratching thing, but believe on me, I will make it funny for you. Just concentrate here. For every derivation we used to assume something, so I have just written in very short point for you. Just consider this assumption. First assumption is the operation, means the cooling must be in steady must be steady, that is the operation must be steady. Okay, it's clear, I think. Second point is no, there must be no heat generation within the fins. Okay, it's very clear. Third point, thermal conductivity, means K must be constant and uniform throughout the fin. Again, it's very clearly written. And fourth, H must be constant. Yes, you might think I can understand steady operation, no heat generation, thermal conduct, but what about heat conductivity? Heat means thermal heat conductivity constant. Yes, yes, you are correct. Near the fin base, it's very less, but as per near the fin tip or in the fin tip, it's very high, because means only this much part. If this one is a fin, all this much, all these parts are, means all these parts, if say this one is fins, all these parts are in contact with atmosphere. So here the fin, definitely H conductivity is larger, but here means if we consider this part here, I mean the very less amount of the surface is, means in contact with air. So here the thermal conductivity is less, but here the thermal conductivity is more. But for the sake of easiness, we just say H is constant. Hello, now let's take an example. Okay, means for derivation of fin equation, let's take an example of rectangular fin. Okay, for the sake of convenience, there is nothing related to this one rectangular fin, it is common for all. We are just taking for the sake of assumption. Just see, say I have say the value of heat entering the this one elemental area be 9. Okay, just suppose, and from after passing this area of thickness, I mean of this one del x, the means heat transfer occurs, means from since the air is surrounded around the fins, so some heat is dissipated, okay, in air. So let's the rate of heat heat convective from the element, that is del x thickness, be 3, and the remaining be qx plus del x. Okay, remaining be 6. From the simple mathematics, we know that 9 equals to 6 plus 3. So 9 is heat entering, means rate of heat conduction into the element, how much heat is conducted into the element. And 6 is rate of heat conduction from the element, how much heat is conducted from the element, that is from the element x plus del x. And this one heat, and 3 is rate of heat convection from the element. Okay, then after putting it's like what we say, just say it, qx equals to qx plus del x plus q convection. Okay, q just rearranging it, we get qx plus del x minus qx plus q convection equals to 0. Okay, just check it out my first video. From there we get h convection equals to h as ts minus t alpha. So bus dividing all the terms by del x. Okay, and putting p into del x in case against as. P is the this one breadth, and x is the thickness, this length. Okay, so this is the area from where heat is dissipated. So hp del x ts minus t alpha divided by del x get cancelled. Okay, and taking limit x tends to 0 for this term, actually here is no del x, so we get d heat conductivity by dx plus hp ts minus t alpha. From my first video, q conductivity equals to kac dt by dx, so this term plus hp ts minus t alpha. Now differentiating this term, k ac are constant, dt by dx, k and ac are constant because we have assumed it. Just revert this video, you will get to know. Okay, so we get this term. Again, by dividing kac we get this term, and by taking m square equals to hp by kac we put, okay, and theta equals to ts minus t alpha. This t is also a difference of temperature, surface temperature and ambient temperature. Okay, just remember it. So this one is linear differential equation of second order. Okay, this one. So solving it, so finding the solution, theta equals to c1 e to the power mx plus c2 e to the power minus mx, where c1 and c2 are arbitrary constant and can be found by boundary condition. So for the boundary condition, check my next video. Okay, see you then.